we will go from there. All righty. So we're going to be now working through 5 different types of equations through the rest of this week, beginning of next week. And so for those, you will be just given the reactants, and then you have to figure out what the products are and write them correctly and balance them. So you're just adding another step to what we have already been doing. And we're going to cover 2 types today, and then those 2 types will be on the quiz on Friday. So the first one that we're going to cover is composition or synthesis reactions. So in a composition or synthesis reaction, you are starting with 2 elements or 2 compounds, and then you're coming together to form one new product. So 2 things that are simpler come together to form one more complex thing. And so you end up with these, you just have one product. Decomposition is kind of like the reverse of those, because you're going to start with your more complex, and then that's going to be broken down. So on this, you have just one reactant. So these are kind of the opposite of each other. These are the 2 that we're going to be going over today. Single replacement we will do tomorrow, and then have a lab on it on Thursday. So on a single replacement, you're going to have an element that's all by itself, and it's going to try to kick something out of the compound. So you'll end up with a new element by itself and a new compound. And on this, we will use something called the activity series. Next one, you have a double replacement reaction. So I have 2 compounds. The cations are going to exchange places, which will lead me to 2 new compounds. And on here, we use solubility rules. And we'll do those next week. And then the last one, which we'll do on Friday, we have hydrocarbon and combust it or burn it in the presence of oxygen. And that always gives you the same 2 products, which are CO2 and H2O. There are other types of combustion reactions, but these are the ones that we're going to be looking at. So that on these, the only thing that might change will be your hydrocarbon. I'm going to put a triangle for change. It should be in there from whatever. When did we start these? Last week sometimes, I believe. Thank you, ma'am. So you'll always have hydrocarbon. It'll always combine with oxygen, and you'll always get these same 2 products. So today we will look at the first 2. And like I said, there's quite a bit of memorization on this. I don't really know how else you can be successful with these 2 besides just working through your practice and memorizing. The other ones, not so much. Probably don't have to do quite as much memorization with the other ones. All right. So, oops. Try that again. So let's start with our composition or synthesis reactions. So like I said, on those, you're going to start with 2 or more simpler substances, and then they combine to give you just one product. And we're going to look, I'm just going to number these because later on when we do the practice, I'm going to refer back to it. So these are just like different examples of how things combine. When I combine 2 elements or a compound in an element, it's not a random way that they're going to end up forming their product. They're going to combine in such a way that they'll become more stable, lower in energy, which means they're trying to fill their octets. So that's why you have to go by these examples, because these are how different compounds are going to combine. The first one would be, I think, of the easiest, the first couple. So my first one, I just have a metal and a non-metal, and they come together to form a salt. And in chemistry, a salt is any ionic compound. So I have magnesium, and that's my metal. I combine it with chlorine, which is my non-metal, and then they come together to form magnesium chloride. On your product side, because that's what y'all are going to be doing, y'all are going to be making your products. On your product side, you're going to be forming a lot of ionic compounds. So you have to check the charges when they're formed to make sure that's written correctly. So in other words, just because this nitrogen has a 2 here, that does not mean the nitrogen is going to have a 2 over here. It has a 2 here because it's all by itself. It's diatomic. Over here, it doesn't need a subscript because lithium is a +1. So you can't just carry your subscripts along or across the yield sign. Sometimes that'll work out, but in general, not. So my next one, I have 2 non-metals, and then those are going to come together to form a molecular compound, and the molecular compounds are the ones that use the prefixes. So I have carbon plus oxygen comes together to form carbon dioxide. Non-metal comes together to form a non-metal compound. And the next one you have, instead of 2 elements, now I have 2 compounds that are combining to form a single product. So in this case, I have sulfur trioxide plus calcium oxide come together to give me calcium sulfate. And you can see it's just kind of added up. 1 calcium, 1 sulfur, 1 sulfur, and then all of my oxygens. So like I said, these, what you're doing on your practice and also on the quiz, they should be really easy to balance, and quite a few will already be balanced. I try to stay away from this one whenever I do quizzes or tests, because it's like there's not just a set pattern it's going to always follow like there are on the other ones that are going to be going. So this one kind of has more exceptions, so I try not to use that on a quiz or on a test. All right, I'm going to move this down a little bit, and we'll start looking at ones that do stick to their pattern. So we got, this was my number 4, my number 5, my number 6, my number 7, and then we're going to add a number 8. All right. So number 4, I have a metal oxide. So that's the metal combined with oxygen. And then it will combine with water. If it will form, if you'll scratch out acid, that should say a metal hydroxide. And your hydroxide is your OH with a -1. So I have my metal oxide, magnesium oxide. I combine it with water, and I end up with a metal hydroxide. So magnesium is my metal. I combine it with a hydroxide, and then I make sure that it's written correctly according to the charges. The next one, I now have a metallic oxide, and it combines with carbon dioxide instead of water. So it's going to give me a metallic carbonate. And your carbonate is your CO3 -2. So once again, forming a new ionic compound, I would have wanted to check my charges and make sure that was written correctly. All right, down here to a metallic oxide and sulfur dioxide. On my numbers. All right, metallic oxide, so metal with oxygen, and now I'm going to combine it with sulfur dioxide, and it's going to give me a metallic sulfite. And sulfite is your SO3 -2. So once again, you can see kind of was just added up, my metal, then my sulfur, and then I combine all of my oxygens to give me my 3 over here on my product side. Next one, a non-metallic oxide. So now a non-metal with oxygen. plus water is going to give you an acid, and it's going to be an oxy acid. That's the type of acid, not a binary acid, oxy acid. Remember, acids start with hydrogen. So once again, you can see it's kind of just added up. My 2 hydrogen, my 1 sulfur, and then I put my oxygen together to get the end of that. And the last one that y'all need to add in, if you'll add a metal chloride plus oxygen, is going to give me a metal chlorate. And the chlorate is ClO3 minus 1. So if I looked at an example of that, we'll just do good old table salt. Sodium chloride combines with oxygen, it's diatomic, to give me sodium chlorate. And then on this one, you'll see it's not balanced. My oxygens kind of jump out at me. I have 2 here and 3 over here. So I'm gonna need to put a 2 so I can get 6 on each side. And when I did that, it changed my sodium and chloride. So I need to come in and fix that with a 2 right there. So really simple to balance if they do need some balancing. All right, those are our synthesis, and now we'll flip them around and make our decomposition. So I do feel like it's, to me, it's quite a few things to memorize, but the decompositions are just going to be a reverse of your synthesis. So it's not like really memorizing a whole nother eight set of different types. So decomposition, we're breaking something down. So you're going to be starting with your more complex compound, and then you'll break it down into 2 more simple compounds. So the giveaway here is that you always just start with one reactant. Probably the easiest ones to recognize. All right, so first couple are real easy. First one, I have my ionic compound, so metal plus non-metal, and those do just break in half back to their 2 elements. So I have sodium chloride, and it's going to decompose or break into sodium and chlorine, which becomes diatomic because it's all by itself. Same thing with my molecular or covalent compound, composed of 2 nonmetals. They're simply going to break apart and go back to the 2 nonmetals that made them up. Some compounds may decompose into an element and a compound instead of 2 elements. So here I have hydrogen peroxide, and when it decomposes into water and into oxygen. So that's like number 3 on the front side. I try to stay away from those because there's not a set way that those always work. So they get to be a little tricky. But starting from 4 on down, there's always going to be a set way. So if I have a metal carbonate, that's what I have here with my magnesium carbonate, it decomposes into a metal oxide and carbon dioxide. So do not draw this line. It doesn't just break into magnesium and carbonate. And I'll see that, even though I'll say it about 3 times or 4 times or 100 times. It breaks into a metal oxide and CO2. That's how it decomposes. And once it does on that particular one, it's going to be already balanced. Metal chlorate, flip over what we talked about on the other side. It will break back down into the metal chloride and then oxygen. Move this up just a little bit. All right, then we have metallic sulfites. So once again, it doesn't just come through and just cut that in half. That's not what happens. A metallic sulfite is always going to break down into a metallic oxide. And then I have sulfur dioxide left out of that. My 6-1. All right, we're going to add one here. Next one, metallic hydroxide. So when that decomposes, it breaks back down into the metal oxide and water. And then my oxy acids decompose into a non-metal oxide and water. Sometimes those can be a little tricky. The way I think of those, I know what I'm going to start with. So let's say that I'm starting with H2SO4, sulfuric acid. I know one of the products is going to be water, so I take that out first. So when I do that, it gets rid of all my hydrogen and it gets rid of one of my oxygen. And then what I have left over, in this case, SO3, that will tell me what my non-metal oxide is going to be. So if you know something's going to come out of it, take that out first and then see what you have left over. And number 9, if you'll add in metallic sulfate, will decompose into a metallic oxide. And sulfur trioxide. So example of that would be magnesium sulfate. There's my metallic sulfate. It's going to break down into metallic oxide, and my metal in this case is magnesium. So magnesium oxide plus sulfur trioxide. And then that one's already balanced if you've done it correctly. So this is your kind of your little cheat sheet. So let's look through a few of the practices. If you'll pull your practice out that you got today. And we'll kind of look how to attack them. So let's start here at the top. All right, so these are synthesis reactions. So you got to know what you're starting with. So in the case of number 1, I'm starting with lithium, that is a metal, and iodine, which is a non-metal. So that's just going to be rule 1. Metal plus a non-metal comes together to give me an ionic compound. So that would be lithium iodide. And then, like I said, sometimes you have to do a little balancing. It should be really simple balancing. I need 2 iodine, so I'm going to put 2 over here, which makes me also need a 2 in front of my lithium. So then if I wrote that out, it would be lithium plus iodine. This is just elemental iodine. It's neutral. When it comes together, it's going to form lithium iodide. Now that ending has changed because now it's part of an ionic compound. Instead of iodine, if you wrote iodide, that would be incorrect because iodide is an ion, and here it's just the neutral diatomic molecule. All right, so that's kind of the simple one, ionic compound. Oops. Oh. Happy Tuesday. Let's see, where is it? All right, let us look at number 4. Skip down to number 4. So on number 4, I have sulfur trioxide plus water. So I'm going to look at all my different little rules and see what it's going to make. So that would also be considered a non-metal oxide plus water. So what is that going to yield? Yes, it's going to yield an oxy acid. You have to go all the way down to number 7. I'll rewrite this since I kind of got myself crooked. All right, so we said a non-metal oxide plus water is going to give me my oxy acid. So since it's an acid, I'm going to start with my hydrogen. Then I would have my sulfur and my 4 oxygen. And then I would double check that formula, and that is written correctly because sulfate is -2. So that's why I had to put a 2 right here. And then I would quickly look and see if I need to balance it, which in this case, I don't need to balance it. So that one would be through. Kaylin, can you wake your friend up that's sleeping behind you? You weren't sleeping? Usually whenever I have my eyes closed and I'm doing this, that's usually when I'm sleeping. I feel like that's when you're sleeping too. No? Okay. All right. Let's look at number 6. Number 6, I have a metal chloride combining with oxygen. What's that going to give me? I think it's going to be look all the way to the end, the one that we wrote in. A metal chloride, all right? So there's my metal chloride, there's my oxygen. So it's going to come together to give me a metal chloride. So that would be CaClO3, 2. And the reason it had to have that subscript of 2 is because calcium is a +2, chlorate's a -1. So what would I need to do to get this one balanced? You need 1 coefficient. 3 in front of the oxygen, right? All right. If you look at number 8, I'm going to touch on number 8. If you look at number 8, there's a Roman numeral behind it that says 2. That's usually what we see in formulas with transition metals. That does not mean that this lead has a charge of +2. That means when it combines over here, then it's going to have the +2. So when it combines with the chlorine, then it has a +2. That's something that I would have to give you or tell you because you don't know what it's going to be. Here, I don't have to do that. I can tell from what this is combined with that the iron is a +2. If it's a +2 on your reactant side, it's a +2 on your product side. So that's just something you have to know to be able to complete the reaction. All right, let's switch over and we'll look at some of our decomposition ones. So just flip your page and we'll do the same thing. Find something, decide what it is, and work on it. All righty. All right, here we go. We got some decomposition reactions. All right, so we'll start with number 1. That is nickel 2 chlorate. So metal chlorate. What does a metal chlorate decompose into? Metal chloride plus oxygen. So my metal is nickel. So it's going to decompose into nickel chloride plus diatomic oxygen. And once again, this had the 2 because nickel's a +2. All right, then we would need to do some balancing. What do we need to do to get this one balanced? Put a 3 in front of the oxygen, and that is balanced. So when I was working this one with my last class, because like I told them, by the time I teach this 4 times, it's like, I sometimes don't even know what I'm saying anymore. I like started balancing this and putting a bunch of coefficients. I got myself all confused. And then I erased all that and started over. And so like I've said a couple of times, if you're trying to balance something and you just can't seem to get it balanced, maybe sometimes erase everything you have and just start over. Because it's like I tried to overbalance it and then I got myself confused. So just kind of a little hint that I found from doing a lot of balancing of equations. All right, number 4, we have iron hydroxide. So what is iron hydroxide going to become? Metal oxide and water. We're down to number 7 if you labeled them. So it's going to become a metal oxide. So my metal is iron. So it's going to become Fe2O3 plus water. Now, if I look over here, this iron is a +3. I can tell that by what it's combined with. If it's a +3 on the reactant side, it's a +3 on the product side. So that's why these subscripts were needed. And then we would need to balance it. What do I need to do to balance this one? I need a 2 in front of that. That one kind of jumps out at me, right? And then what else do I need to do? So how many hydrogen do I have? 6. So I need to put a 3 in front of here. And I'm hoping that that took care of my oxygen, which is in 2 different places. And did it take care of my oxygen? Yes, it did. I have 3 oxygen here and another 3 oxygen right there. So notice I left that oxygen to the last because it was in 2 places. That made it a little bit harder. So that's how you got to work through those. You got to see what you start with and then use your little sheet until you have it memorized to see what you're going to end up with. Okay. Well, will not be so much memorization tomorrow or on Friday. This is probably the one that to me you have to do the most memorization on. All righty, y'all got about 10 minutes to give a few a try. Let me know if you have any questions or if you get stuck on anything or you think my key is wrong, because that is always a possibility. Try to double check, so sometimes it happens. Let me stop this real quick.